Okay, I wanted to just do a quick example of using the spectrogram to analyze guitar signal. So actually I need to show you one other thing here. I had previously run this command, so let me put that over here so we can just look at that. Forgot to put that in there. So I have this guitar1.wave file. Many of you have heard that before. I read it in using audio read. It goes into a column vector X. That's audio read always does the column. It tells you if you call it with two output variables, the second one will be the sampling rate that was used to create that wave file. And there are other ways to call this with different input arguments and different output arguments, so you can type help audio read if you'd like to know more about that. Second line here is just doing exactly what I spelled out in one of the lecture notes, on the DFT processing, where at the end we talked about short time Fourier transform, and as I said, even though this is called spectrogram, it really computes what's called the short time Fourier transform. So as input we put in the signal X. So this is a 9-second clip of a longer guitar piece that I recorded, maybe I'll post the full thing. It's just some chord progression that I made up and a little melodic solo that I put over it. That I made up at some point. So you put in the signal X. I've chosen a Hanning window. It's not super crucial which window you pick, but I like Hanning. That's pretty good. And I'm using 2048 as my block size. The amount of overlap is 512. You can adjust that if you want. I forget what the 8192 is here. Zero padding. That's the amount of zero padding. And then I put in FS so that it will properly compute the frequency and time vectors. And you can play around with this with different block sizes, different overlap amounts, and different amounts of zero padding if you want. The surf command plots it, and then I limit it to 5,000 hertz on the y-axis. So if we come over here to this figure now, this is what's computed. I didn't label my axes here, shame on me, but just doing this quick. This is the time axis, so this is in seconds, and you can see we go from about 0 to 9. And I will admit the way that I plot this using the surf command is a little funky on the time axis, but it works okay. It gives you the basic idea. And then this is the frequency axis, and you can see we're going from 0 to 5,000, and that's in hertz. And kind of coming out of the screen is the height of the surface plot. Tells you the contents or the values that are computed in the short time Fourier transform. And you can see I'm plotting the absolute value of this, so that really is the spectrogram when I plot it. And so at each instant of time, if you draw a vertical line, you can think about that slicing through a Fourier transform at that instant. And so these bright lines here will indicate where the different harmonics are in the note that I am playing at that moment. So right here, you can see that we're at something that is around a little bit above 500 hertz, maybe. Well, maybe a little bit below 500 hertz. Yeah, probably about, I would say, pretty close to 500 hertz, 494, because I think I'm playing a B note there, and I'll explain this in just a little bit. You can see various structures, and I'll play the audio in just a little bit, but I just want to show you a few things. So this starts off with me sliding up to an E note on the 9th fret of the G string. Again, if you don't know guitar, it doesn't really matter, but I'm sliding up, and you can see that slide right here. And remember, notes create harmonics, so this fundamental an E note is at about 330 hertz. And you can see that's in about the right location. So I slide up, and you can see this discrete step that's kind of going on the frets as I slide up. And then I hit that E note, and you can see all the harmonics. Interestingly enough, some of the harmonics are so weak they don't show up. There's a kind of a threshold that this short-time Fourier transform display below which it will not really show up very well. But you can see here are the harmonics. There's one kind of missing or very weak, then another one, and so on. So I slide up to the E note and I hold it. And then the next thing that I do is I play a B. The way that I play that is I actually start fretting on the 10th fret of the B string. So I'm actually in position to play an A, but I pre-bend up a whole step up to a B. So pre-bend just means that you bend the string before you actually strike the note. So when I strike the note, if I've done the pre-bend well, I should be striking it right at the B pitch. And you can see, at least without zooming in, it looks like I nailed that pretty well. I don't change, up or down much after I strike that. Maybe a little bit when we hear it, but a pretty good pre-bend. So E to B, this strong thing underneath is probably the rhythm guitars. There's actually 2 rhythm guitar parts going on in the background. So I go up to the B and I pinch it. I just stop it. So it's like, and then play the B again, and it's pre-bent. So then I unbend it back down to an A. So it's, and then you can see the step down that I do. I play 3 notes there. Actually 4 notes. B to A. I didn't work this out. Probably G back down to E. And then I slide up to a C on the B string, 13th fret. Down to a B. And then you can see that I wiggle my finger while holding that B on the B string on the 12th fret, which is an octave B. And you can particularly see that vibrato very much accentuated in the harmonics. So then I hang on that B and I wiggle it back and forth. That's vibrato. And then I hold that for a while, and then again a slide up. Again, now I'm holding that without any vibrato really, and I hold it, and then the very end, and that's where the recording stops. Okay, sorry for my poor singing. It's kind of hard to sing a guitar part while you're also trying to talk. So here's the program Audacity, a nice little audio recording, editing, free software. So if you want to do any audio recording and editing and you don't want to spend a lot of money, Audacity is a pretty good program. Has lots of editing capabilities and effects and so forth. It can do a spectrogram, but I don't really like the one that it does, so I liked having the ability to do it in MATLAB. But anyway, I'm going to play this, so let's see. I've lined this up the best that I can. I'm a little bit off, it looks like maybe. Maybe I'll slide this back this way just a little bit to see if we can line that up a little bit better. And then let's go to View and say Fit in Window. Let's slide this over. I thought I had this set up, but I maybe didn't do such a good job. All right, I think that's kind of lined up. So I'm going to play this. You'll see this little vertical line. You can just barely make it out a little bit there. I don't know what the hell I just did there, but hopefully I didn't screw anything up. I don't know what I'm doing here. Well, hopefully this will work. If not, I'll try to figure it out. So I'm going to play this. You'll see a vertical line sweep across to show you where in this record it is. And why is this all solid like this? Well, we'd have to zoom in on this to see the actual waveform a little bit better. We are so zoomed out. This is 9 seconds long that things just look solid. Wow. I don't know. Let's try to zoom in on this. Maybe we can do this. Let's see. View, zoom to selection. Yeah. So there it is. Now we're seeing the up and down of just that little selection. So let's zoom back out. Fit in window. All right. Let's see if we can do this now. All right. Let's see if it'll play. Here we go. Okay, and that's all there is. I'll post the longer one if that unresolved ending bugs you. You can listen to the longer one. But hopefully if you kind of play that part of this video back several times, you can kind of watch to see what's happening. So the short time Fourier transform is a tool that's used in a lot of audio signal processing, and we'll get into a little bit of it at the end of the course. Hopefully we'll have time to do that. It's used in a lot of different things, like changing time scale, changing pitch. Auto-tune uses it, and then other things like automatic transcription processing will use this, and we'll do pretty much what I just did for you, right? Like, oh, okay, sliding up to an E, going to a B. Now it doesn't know that I'm pre-bent, so it's maybe not that clever, and so forth. But that's a big area of research, is automatic transcription from a signal. Okay, so that's it. Hopefully this is just a quick little fun thing for you to take a look at.